Now let us look at the pros and cons of the write caching strategies that we have discussed. First, let us take a look for a write aside strategy. Now in the write aside strategy, we directly write to the database by passing the cache at all. As you can see in this diagram that there is an arrow 1 which is directly writing from the application to the database. Now what would be the pros of this strategy? Think about it. First and very obvious one is that we have faster writes here. Why faster writes? Pretty simple, right? The data is directly written to the database. We don't need to update or write to the cache. Now since we only write once and that is to the database, writes naturally become faster. This is in fact a great strategy for write heavy operations or write heavy systems where we don't need to update the cache immediately. Second is cache independence. Now what do I mean by this? Basically in this strategy, the cache is kept separate and doesn't directly sit in the middle of the write process, but rather it is kept aside, hence the name write aside strategy. So this effectively means that even if the cache fails, it won't affect the database writes. So the system can keep working even if, let's say, the cache is temporarily down. So basically we have increased fault tolerance of our system. Now for the cons, firstly, there would be slower reads. Why? Since we are bypassing the cache during writes, the data won't be available in the cache right away. Now when we try to read the cache, it could lead to a cache miss, therefore requiring the data to be fetched from the database first and then added to the cache. Now all of this, cache missing, getting the data from the database and then the cache getting updated and then serving the data to the users would make our reads pretty slow. Next, we have the risk of stale data. Now what do I mean by this? Let's say we update a user's address in the database using this strategy. Now since the cache was bypassed, it won't have this updated address. Now if the cache already has this user's data, it will be the old or the stale version without this new address. So wherever there is a read request of that user's data, it would serve the data from the cache first and therefore the data with the older version or the older address would be served. In fact, we would have to wait until the data in our cache expires and is invalidated and removed from the cache. This is only when we would face a cache miss and then the cache will be updated with this updated data or our new address. So basically, we have the stale data problem and only cache miss would update that stale data to the new data. Next, let us move to the write through strategy. Now in the write through strategy, the application first writes the data to the cache writes it to the database sends a confirmation back to the cache, and then the cache would send a confirmation back to the application. So the pros, first, we would have no stale data here because every write operation, whether it is creating a new record or updating an existing record, and they would go through both of these cache and the database at the same time or aka synchronously. So if we change, let's say, a user's address, it's updated in both the places instantly, keeping the cache and database perfectly in sync at all the times. Second, we have faster reads here. Now reads here are pretty quick unlike the previous strategy. This is because the data is always available in the cache. Unlike the write aside strategy, we don't have to wait for the cache miss to update itself since the data is already cached on every write operation. Let's come to the cons. The first con here would be slower writes. Now here the writes would become slower when we compare it to the previous strategy because each operation would update both the cache as well as the database. Now in the previous strategy, we only wrote to the database, but here there is now an added extra step with the cache, adding to the latency. Second is cache dependency. What does this mean? Now in this strategy, the cache becomes a crucial component because all the writes would go through the cache first. Naturally, if the cache fails, we cannot write to the database, which could cause the whole operation to fail and could lead to system downtimes. Now let's move to the write behind strategy, which is sort of an improved version of write through strategy. Now here, unlike the previous two strategies, we would have best of both the worlds. We would have faster reads as well as faster writes. Let's see how this works. First, the application would send the write request to the cache. Cache would be updated with this data, and then a confirmation is sent back to the application. Then the steps 3 and 4 will happen, which is effectively cache updating the database. Now the steps 3 and 4 here would happen asynchronously or in the background, and this would happen after we send the confirmation back to the application. Basically, our application doesn't have to wait for both the cache and database to be updated before receiving the confirmation. It could get the confirmation just after the cache is updated, and the cache to database would be updated behind the scenes asynchronously. So what would be the pro of this strategy? Faster writes. Now this strategy solves the slower write problem pretty smartly. When the application writes data, it goes to the cache first, cache updates, and the application then immediately gets a confirmation. After that, as you know, the cache updates the database asynchronously in the background. Second, we would have faster reads here. Now reads are also faster here, pretty obvious, because the data is written both to the cache and the database, and therefore whenever there is a read operation in the future, it could be served from the cache. Let's come to the cons. Now the first con would be risk of data loss. Basically, the asynchronous database update happening from the cache to the DB is efficient and it helps to solve the slower write problem, but it can also lead to issues on the other side. For example, if this background asynchronous update from the cache to the DB doesn't go through for some reason, then the data won't ever reach the database. Now, since the cache is volatile and is temporary, it could lead to data durability issues in those cases. Second is cache dependency. Just like the previous strategy, the cache sits right in between the application and the database. Every write goes through the cache. So if the cache fails, we cannot write to the database, which could lead to downtime for that operation and also for our system.